Hi. The first thing I want to inform that Newton was not the first person to discover gravity. Newton discovered that gravity was universal. Galileo discovered gravity. Today, we're going to talk about Newton's first, second, and third law. First thing I want to talk to you about is inertia. Do you know how inertia works? If you don't, let me give you an example. Okay, let's say you're on the passenger side of a moving vehicle. Do not try this while you're driving. You're on the passenger side of a moving vehicle. Now let's say you take off your full cell ID. And you take the string that's on your full cell ID and you wrap it around the actual ID as the car is moving. And you toss your ID up and down as the car is moving. Your ID is reacting as if the car was still at rest. Now, I'm about to give you another example of Newton's first law. Okay, let's say we have a ball, and the ball is moving downward at the velocity of 10 meters per second. At this point, the ball is moving at the state of rest. The ball is also a vector because it has a direction that is downward and a velocity of 10 meters per second. And then a kid comes along that's a non-zero force kicks the ball. When the non-zero force kicks the ball, he or she are applying external force. Now, let's talk about Newton's second law.
Hey yo, peep this.
Now, I'm about to explain to you how acceleration works. Okay, let's say I'm pushing a table with 20 newtons, but a friend come along and help me push the table the same direction with another 20 newtons. I just doubled the force, and when you double the force, you double the acceleration. Because twice as much force produced, twice as much acceleration also produced. Now, let's do some equations on force, mass, and acceleration. You can set these equations up 3 different ways. Depends on what you're trying to find. You can set it up force equals mass times acceleration. Acceleration equals force over mass. Mass equals force over acceleration. It all depends on what you're looking for. In this case, let's say we want to find acceleration. Let's say we have 100 newtons and 25 kilograms. What we do, we divide the 100 newtons into the 25 kilograms and we come up with 4 millimeters per second square. Okay, in this equation, let's say we're looking for the mass. We're going to say 60 newtons, 3 meters per second square. What we do is we divide the 60 newtons into 3 meters per second square and we get the mass. And that would be 20 kilograms. Now, this equation is a little different. We're looking for the force. Let's say we have 20 kilograms and 30 meters per second square. What we do, we multiply 20 kilograms into 30 meters per second square, and we get the force of 600 newtons. Okay, let's talk about another second law when acceleration is lowercase g. We call that free fall. And when an object is at free fall, there's no force acting upon it except gravity. And an object falls 10 meters per second. The greater the force, the greater the mass, but same acceleration. For example, let's say me and you jump out of a plane. No parachute. My mass is greater than your mass. I'm going to hit terminal velocity before you hit terminal velocity, but we still going to hit the ground in the same velocity. Okay, let's carry on to Newton's third law, action and reaction forces. And together they are called interactions because neither force exists without each other. Now let me ask you this. Let's say you're on a road trip and a cat jumps in front of the highway and you hit the cat. Your car and the cat hit each other with the same amount of force. Tell me why the cat got smushed and your car kept going. I'm gonna tell you why. Simple, because your car is more massive than the cat.